everyone, I am Aishwarya, Assistant Professor from Department of Computer Application in SFR College, Sivagasi. Today we are going to talk about introductions of data structures. These are our learning objectives. First one, what is data structure? Next one, classification of data structures, operations on data structures, algorithms, time and space complexity. Next, what is data structure? Data structures are the fundamental building blocks of computer programming. A data structure is a particular way of storing and organizing data either in a computer memory or on the disk storage so that it can be used efficiently. It is also used for processing, retrieving and storing data. Next, classification of data structure. Data structure is classified into two categories: primitive data structure, non-primitive data structure. Primitive data structure are the fundamental data types which are supported by programming language. So, example of some basic data types are int, float, character, real and boolean. Next, non-primitive data structure. Non-primitive data structure are data structures which are created using primitive data structures. Example of some data structures are linked lists, stacks, queues, trees and graphs. And also it can be classified into two categories: linear and non-linear data structure. Next we are going to see about what is linear and non-linear data structure. Elements are stored in a linear or sequential order which is called as linear data structure. Example of linear data structures are stacks, queue, linked list and array. Next, elements which are not stored in linear or sequential order which is known as non-linear data structure. Example of non-linear structures are trees and graphs. Next we are going to see about what is array. An array is a collection of similar data elements which are stored in consecutive memory location and are referred by an index which is also called as subscript. Here the diagram contains 6 elements. In C, the array index starts from 0. Here the first element 2 is stored in 0th index and the second element 4 is stored in first index and so on. The last element 3 is stored in n-1 index. Next, what is linked list? A linked list is a very flexible dynamic data structure in which elements, that is a node, form a sequential list. In this linked list, each node is allocated space as it is added to the list. Every node in the list points the next node in the list. Here the diagram shows the 4 nodes of linked list. In this linked list, every node is divided into 2 parts. First one is the information or data of the node and the second one is the pointer or address of the next node in the list. The last node in the list contains a null pointer to indicate that it is the end or tail of the list. Since the memory for the node is dynamically allocated when it is added to the list, the total number of nodes that may be added to the list is limited only by the amount of memory available. Next, stack. What is stack? A stack is a linear data structure in which insertion and deletion of elements are done at only one end, which is known as the top of the stack. The stack is also called as last in first out structure because the last element which is added to the stack is the first element which is deleted from the stack. The diagram shows the array implementation of the stack. Every stack has a variable top which is used to store the address of the topmost element of the stack. It is this position from where the element will be added or deleted. There is another variable which is called max, which is used to store the maximum number of elements that the stack can store. If top equal to null condition means that stack is empty, and the another condition top equal to max minus 1, that means stack is full. What is queue? Queue is a first in first out data structure in which the element that is inserted first is the first one to be taken out. The elements in the queue are added at one end is called rear and the removed from the another end is called front. Every queue has front and rear variables that point to position where from the deletion and insertion can be done. Here the front equal to 1, rear equal to 5. If add the new element to the queue, the value of the rear is incremented by 1. If delete the element from the queue, the value of the front is incremented by 1. Using rear equal to max minus 1 condition to check whether the queue is full or not. This condition is checked when insert a new element. Using rear equal to null or minus 1 and front equal to null or minus 1 condition to check whether the queue is empty or not. This condition is checked when we delete an element from the queue. Tree. What is tree? A tree is a non-linear data structure which consists of a collection of nodes arranged in a hierarchical order. These nodes are connected by edges. The topmost node of the tree is called root and the nodes below it are called child nodes, and the remaining nodes can be partitioned into disconnect sets such that each set is a subset of the root. Each node can have multiple child nodes and these child nodes can also have their own child nodes, forming a recursive structure. Binary tree. The simplest form of tree is binary tree. A binary tree consists of a root node and left and right subtrees, where both subtrees are also binary trees. Each node contains a data element, a left pointer which points to the left subtree, a right pointer which points to the right subtree. If root equal to null, then the tree is empty. The first topmost node in the binary tree is called the root and the bottommost nodes are called leaves. Here in the diagram, root node is node 50 which have right and left subtrees. Node 17 is the left child and the node 72 is the right child of the root node 50. The first left tree of the root node consists of the nodes 17, 12, 23, 9, 14, 19. Similarly, the right subtree of the node consists of the nodes 72, 54, 76, 67. Graphs. A graph is a non-linear data structure which is collection of vertices, also called nodes, and the edges that connect these vertices. Graphs represent the relationship between different vertices. A node in the graph may represent a city and the edges connecting the nodes can represent roads. Here the diagram shows the graphs have 5 nodes. Operations on data structure. Transversing. It means to access each data items exactly once so that it can be processed. Example, to print the names of all the students in a class. Searching. It is used to find the location of one or more data items. Example, to find the name of the student who got 100 marks in data structure. Inserting. It is used to add the new data items to given list of data items. Example, to add the details of the new student who recently joined the course. Deleting. It means to remove or delete a particular data item from the given collection of data item. Example, to delete the student name who has left recently. Sorting. Data items are arranged in ascending order or descending order depending on the application. Example, arranging the student's name in alphabetical order. Merging. List of the two shorter data items can be combined into form a single list of shorter data items. Example, delete the particular student details, search the list of the students to find whether the record exists or not. If it exists, then which location it is present, then that the details can be deleted from that particular location. Algorithm. An algorithm is basically a set of instructions that solve a problem. The typically definitions of the algorithm is a formally defined procedure for performing some calculation. It provides an effective procedure for solving a problem in finite number of steps. Time and space complexity. Analyzing an algorithm defines the amount of resources needed to execute it. Time complexity of the algorithm is basically the running time of the program as a function of the input size. Space complexity of an algorithm is the amount of computer memory required during the program execution as a function of the input size. Thanks for watching this video. I hope everyone understand about what is data structure, classification of data structure, operations of data structure, algorithm and time and space complexity. Thank you for watching. Thank you.